And this is Manuel and Nicolas. Welcome. Introduce yourselves.
All right,
Thank
so hi everyone. So to introduce myself, my name is Nicolas. I work as a security engineer in Switzerland, so I do pen testing for a living. I also do a lot of CTFs everywhere in the world. I do speak at different conferences like DEF CON, Hash Days, etc. about various subjects like web app security, hardware, vending machines, etc. I'm also a hacker, but in the mad scientist's way, since I like to break stuff. Most of the time I break stuff and I cannot repair them. But I like to crack open some things, try to learn how it works, how it functions, and hopefully try to find nice things to actually show people how things works, etc. I also love beer, and I brew them myself. So maybe if you want to chat with us tomorrow or this evening, you can just buy me a beer and I will chat a lot more.
So for me, my name is Manuel. I work in the same company in Switzerland. I'm doing pen tests. I'm also a member of the team 0 Day Sober for the CTF. I'm the developer of Fireforce. It's the Firefox extension for performing brute force attack on the Formula. And I'm a black metal fan, so Norway is really a good place for me. So for introduce, we talked a little about password. We all know password sucks. It's not cool, it's not easy, but it's used everywhere. So managing password is really hard. You need to have different password for every seat. You need to have strong password. We tend to reuse password and don't have password scheme. Of course, there are a lot of password manager. It's a good thing, it's secure. You only need one password for control them all. A lot of them exist in different format, in different platform. But password manager also sucks, because if someone gets your root password, he can access all your data. There are a lot of tools for cracking password. KeePass2Join, the password safe cracker. How do you use your password manager in travel? How do you back up your database? And how do you be sure that your data is encrypted and secure? So for the backup, do you really want to put your database in the internet with Dropbox, Google Drive, or Mega? Are you sure it's really a good idea? We see in the past that this solution has been compromised. So it's possible to have access to your data. And of course, now there is Prism. So the government has access directly to all the data and directly to all your password. So what we can do, we think that passwords are like keys, but for our online access. So why don't we store them or use them like real keys? You always have your keys on your pocket. Maybe you have a backup of your keys, but you don't care because you never lost your keys and you never give your keys to anyone. So we create a project named Password. It's like keyring, but it's for your password. You always have the device with you, and you use them when you want to. So why we choose the name Password? Because we manage password with hardware. So it's the combination of the two names. With a strong Belgian accent, it means Steve. It's a passoir. And although the name password is already used, so we need to change double S with double 5.
Because it will be sufficient.
So what are the features of a password? It's easy to use. We have 4 touch buttons to navigate, one LCD screen, 1.8 inches, and we develop a client application for create your password and some stuff. It's safe to use. Everything is encrypted with AES key. The password and the data are stored in the SD card, and the key is stored on the device, and it is not possible to retrieve it. We hope so. You need a PIN code to unlock the device before you use it. And when you want to unlock the device, if you make it false 3 times, the key is reset, so it's not possible to find it. You can use password for the user password and also for OTP. So at this time, it's only compatible with TOTP implementation. It's the one used for the Google Auth, and it can type your password for you because it's a TNC. So you can just plug in, and it's viewed as a keyboard, and it automatically types the password for you. And it works on nearly every kind of device. We make some tests on Android phone, and it works. The device is free to use. After the conference, we post all the code source and even the plan for the case, so you can print your own. And it's really easy to make one. You just need some soldering iron and a friend with a 3D printer.
Thank you. So, to build a password like we did, you only need a TNC 3.0 that you can buy for $19. You also need to have a TFT LCD screen with a SD card reader that you can find for $12. An SD card on Amazon, I found them at $7. Maybe you can find cheaper ones on, let's say, Alibaba or things like these. Access to a 3D printer. It depends on if you have, I think you have a hackerspace in Bergen, right?
Yeah,
Should.
Yeah.
You should. All right, so maybe they have a 3D printer, or if you have a hackerspace near you, maybe they have a 3D printer and they can do it for you. You also need wire and solder. Be careful, you can burn yourself. I did several times by making this one. So the main component of password is TNC 3.0, I'll say. It's an ARM core. It has many in and outputs. It can use UART serial lines. It can use SPI lines. It has capacitive inputs, so you can detect if you use your finger to actually activate an input. That's a great thing. You can use it with the Arduino IDE. Everyone knows the Arduino. And one of the cool thing is that it has an internal RTC, so you just need to add a simple crystal on the board, and with a battery, you can save the date and time, which is quite useful for the OTP. And yeah, it's just awesome. You can do many, many things with this. This is really great. So, as we have told you, everything is written using the Arduino IDE. So you can just get the code, write it. I tried to make as many comments as possible, so it's quite easy for you to actually know exactly what happens and customize it on your needs. You can change, let's say, the screen colors. You can change the pin code. You can change the number of lines, the size of the lines that are written on the screen, etc., etc. It's really easy to do it. So, yeah, just try it and have fun with that. All the things that you need to change are on the beginning of the source code. So normally you have to change the AES key. You have to change the master password that you can use to unlock the device. You can also change, if you like to add more buttons, you can add them in the code. There are some constants to actually know what you can do with the buttons. So you can add one of them, two of them, or anything like this. Normally it's pretty easy. Regarding the SD card, we use a simple FAT system. So every account you create and store in Passware is stored in a single file, a simple file. So it's easy to create the backups. You just plug the SD card on your PC, copy the files, get them somewhere, and that's it. And the only problem is that the file names are limited. So you can only create files that are 8 characters long. That may be a limitation. So if you navigate using the Passware, you cannot set account names that are longer than 8 for the moment. That may be a problem. Just to show you, this is the file format. So we have a header with 42, just a random value. Quite random.
Nice try.
Then you can choose the file type. One is for a username password file. 2 is for an OTP file. You can add, as having project, to add like 3 to encrypt a file, a complete file. So you can just upload a file that will be stored securely, I hope, in the device. And then after that, you can have many sections which contains an ID. For the moment, we only have username, password, and then the length of the data, and then the AES blocks that are encrypted containing your data, your username or your password. Everything is encrypted. The username, the password, the seeds, etc. So normally, it should be quite secure. The most important thing to actually protect is the AES key. So what do we do exactly inside the TNC is we only load the AES key to RAM only when the password is unlocked. This is important, so you cannot just plug it and the key will be loaded. It's only loaded when you actually unlock the device. So normally from an external point of view, you cannot actually connect to the TNC and get the key with a bus pirate or a debugging access. Normally, it should be working. The AES key is normally stored in the EEPROM. Again, we plan to use the internal fuses of the chip to protect the EEPROM from being read with an external tool, or if you just remove the chip and plug it in an EEPROM reader, you cannot actually get it normally. And yeah, the AES key is cleared from memory as soon as the device is locked again. So just unplug it. It will it will clear the AES key from memory. And one of the thing I was thinking also about changing the way the AES key is stored in the device. I was maybe thinking to store the AES key, one half of the AES key in the program memory of the chip, and the other half in the EEPROM. So if you want to actually get the whole AES key, you'll have to find a way to get into the program code and get the key. And afterwards, you have to actually find another way to get the EEPROM, access to the EEPROM to get the other part of the key. So it will be much difficult if you find or if you steal a password from someone to actually get the right key. I think that would be much efficient to actually do it that way. Regarding the memory, the problem is that it's a really small chip. It has not many RAM. It has, I think it's 16K of RAM. So it's not that easy to actually encrypt or decrypt large block of data. And you have also to load all the AES stuff into RAM to actually compute everything. So there are many constraints to for it to be efficient. So we have tried to actually clean the memory as soon as it is not used anymore. We are trying to clear everything, just remove the memory blocks, clear them to 0 if we actually load the password. We just clear it right after it has been used. So normally you won't be able to retrieve some data while it's in use, or even if it has been unplugged. To be more efficient, the password uses serial communication with your laptop. So when you plug it, you can just keep a button pressed to actually get into a special mode, which is the command mode. So as soon as this command mode is activated, you have to write your PIN. And when you have made your PIN, that's strange, right? Okay. The serial line is activated, and we've created a client application to send commands to the password, to store new passwords, to delete an account, to modify an account. If you've changed your password, it can be it can be updated on the password. This is a good thing. One of the other thing is that you can only push new data. You cannot retrieve it from the application or from the serial mode. So it's kind of a box. You just put your secrets in that box. It will be encrypted, and you cannot get it back directly. The only way to get data back is to actually read it on the screen, or if you want to type the password, press a button, and it will type your password in the field you have selected. That link is also used to synchronize the internal clock. So if your OTP is not working anymore, maybe you should synchronize the RTC. Normally it worked quite well, as the test we've done seem to be really good. But there may be some problems with the RTC on the long-term use. Regarding the communication protocol, it's quite simple. It's quite the same also as the file system. You can just push new commands to say that, okay, create this new file on the SD card and store in the section of the username that value. You just send it clear text. The password will encrypt it, store it in the SD card, clean its memory, and your password is protected in the device. As we said, there are two modes. The command mode, which is a simple serial line. And in the normal mode, the device is only seen as a USB keyboard. So you can just use it to actually type your passwords for you. That's a great option. The application is developed in Python with Qt4 interface. It's quite a simple interface. Just have on the left the tree of the files, the files and folders that you have stored. You can create a new folder. You can add a new account and create an OTP by just putting the name of the account and the seed that is used, and it will do all the rest for you. The communication starts with the password sending 4242, again random values. Then the client application just sends its command. The password will reply with a 0 if something went wrong, or with a 1 if everything went okay. There are commands to actually lists the root directory. So the command is, can you see it? Okay, so the command is for listing. 01 is the length of the parameter, and slash is just read the root of the SD card. The same for the username. 01 is the command. 11 is the total length of the packet. 5 is the length of the file, which is /toto. 01 is for the file type. It's 01. It's a username password kind of file. 01 is we want to update the field number 1, the username. 8 is for the length, and password is the new value that needs to be stored in the password. So it's quite easy. Again, everything is documented. So if you like to create or add a new comment, all the processing stuff is created. Just add a new comment, a new function in the code, and you're ready to go. Again, if you like to create a new client application, everything about the protocol is documented. So you can create a new application if you like to in .NET or everything else. So it's time for a demo now.
I'm going to try a live demo.
Don't see it.
So I'm connected to my VPN, and I want to connect to my Raspberry Pi in my home. So the device is here, and I just plug it. I need to unlock the device. After I show a video of what I do in the device. Hmm? I select my Raspberry. Normally, I just hit the enter button, and I can log in. So, I can show you. No. Okay, it's what's happening on the device. So I select the private folder. It's the value for the Raspberry with my user and my password. Then just hit the enter button. Everything works. So the roadmap now it's a beta version. You can see it. Only the basic function working. We release the code after the conference. Normally we have a first stable version for January. For the moment, we use a null IV, and we it's your ID. And we want to add an ID which is stored in the start of each file. Use the hardware fuse to protect the EEPROM. It's not in place for the moment. And we want to fix the problem with the communication and with the file format. The future improvement, we want to create a password generator, so we can use the touch button for, you just pass your hand in the touch button for generate password. Be compatible with other UTP protocol like HOTP. We want to use USB as a file storage, but for the moment, TNC 3.0 is not able to read a USB. Is right on.
Cannot act as a USB key for the moment. So on the previous versions, the TNC 1.0 and 2.0, there is the possibility to actually act as a USB drive. So we might be able to emulate a file. So maybe you can store your SSH private keys on it. It will be stored like every other password. And if you want to actually get them back, just press enter, and it will be mounted as a USB drive, and just copy the file, so you can use it to actually log in as with your SSH private key.
And why we are here? Because we need to audit the project. Maybe we make some mistake. Maybe there are some bugs, and we really suck at crypto. So we think we're doing the things good, but maybe it's not the case. And we have basic knowledge of hardware hacking, but maybe it's possible to get the key from the EEPROM in a way we didn't think. So, sorry, we need you. So come talk with us and download the project, make your own, report the bug, and we can improve all the projects.
Well, you store all this on hardware in your pocket instead of somewhere in the cloud.
Mm-hmm.
I still need a backup though.
You can do it.
Yep.
For the moment, you cannot actually back up the AES key. It's only stored on the device, and there's no way for the moment to actually get it back. So we don't know if it's a good thing or not to
Export
actually
to
be
Excel.
able to export the key or not. So it depends. It depends. We were not sure that it would be safe to be able to actually read the key in a way or in another. So for the moment, it's only on the device, and there's no way to actually get it.
So you definitely should not try to export it.
Yeah.
What you can do though is built-in backup function that will essentially decrypt all the data, encrypt it with the user-supplied backup password, and send it encrypted data out to the device for that purpose.
Well,
This is how it's done in other systems.
okay.
In big,
Another thing, yeah.
that is roughly this way. So it is much better than just exporting the master key. Your AES key should not be exportable.
Mm-hmm.
Should never be.
Hello. Yeah. Okay. That's again, you can set the key as you want. So you need to actually put the key when you start the password. You have to set the key in the EEPROM first. So you have to use a key loader that just sets the key value that will be stored in the EEPROM at the moment. and afterwards you can actually flash the password with the right firmware that will use that key. So there is a moment in the life of the of the password that you actually have to write the key by yourself. So maybe you can just copy it on a sheet of paper under your keyboard. That's what you need to do, right? So yeah, there is a moment where you know the key and you have to set it. But afterwards, I think the best way is to not be able to actually retrieve that key.
I have lots of questions and comments.
Okay.
And I'll try to be not too harsh on you guys. Because I like the idea,
Mm-hmm.
but I think the usability sucks.
Mm-hmm.
It's a device with a small screen with 4 buttons.
Yeah.
And even with a single button, it's easy to see people, they just don't understand how to use a single button. And you most probably haven't done any usability cases on how big should the display be and what the kind of font should be using. And I'm not sure if you have implemented Cyrillic or simplified Chinese support into your device.
Well,
and of course you don't have RFID or Bluetooth support.
Unicode in general.
And it's a hardware device, and everybody will either lose it, somebody will steal it, or they will just forget it at home.
mm-hmm.
Like Jan Fredrik told me a long time ago, two-factor authentication is usually one thing you remember, one thing you forgot at home. That's the simple thing. So in a way, we do need a backup solution, but we can't have a backup solution which is insecure. That's a challenge for such a device. And it's very easy to make as long as you do have access to a 3D printer, which I don't know anybody who has one. So eventually I have.
Thank you.
Problem solved. Okay. One for you, one. I got that one. But there are so many more things. I mean, kudos to you guys for doing this because it's really interesting. But again, I think also our friends from Cambridge might have a couple of comments for you later on as well, because they are working on a Pico project and they are trying to solve, in a way, the same problem you are, getting rid of passwords or having to remember them. But they are trying to create a device that you can use to authenticate to anything, and you will not have to remember or relate to usernames and passwords at all, basically. If I understand the project right. So that's you need to talk to the Pico people as well from Cambridge.
Sure.
Absolutely. There are so many things about the usability aspect of it. And when I go around look at websites, all kinds of security solutions, or attempted solutions to solve different problems, they can have very good security, but the usability is below 0. And then you can go to people that work with usability design, and they can make usable solutions, but security completely sucks. And finding a combination of those two is very difficult. It's very rare to see that. And just a month ago, 2 months ago, there was a presentation in Moscow where people from Facebook were presenting, the security team at Facebook was presenting. And Facebook has now decided to use 2 different solutions for two-factor authentication for all employees at Facebook. The first device, the hardware device, is the YubiKey from the Swedish company Yubico, which I guess you know about. And the other solution is a more software-based solution from the Duo Security in the US. And both Yubico and Duo Security are now, of course, using absolutely all kind of marketing channels to market the simple fact that their solutions have now been picked by Facebook to be used for all employees. And in case you would ever consider making money off this, those are the guys you're competing against.
No, again, it's just a hobbyist thing. I think it's just for people that the thing is that we think that you add security by keeping the passwords on you. That's the difference between every other solutions that you can find, like LastPass or KeyPass or things like this. That is actually stored on you on your laptop. That also can be stolen. So yeah, it's quite they are the same problems, but yeah, since passwords are still used everywhere. So this is our proposal for a solution for that kind of problem. We don't. It's not the purpose to be sold or things like this. It's just to have something that is quite cheap to create, that you can do it on your own
And
with a 3D printer, or you can use another box, something like this. And or maybe they just ask me. I'll print you a box and send it to yourself if you want to. So no, this is just a hobby, and we are trying to provide a way to actually have a device that is quite good to use. Maybe it's not the best way to do it. Maybe there are improvements to. So that's why it's open source. You can just improve it the way you like it.
So far, how much time or how much effort have you put into trying to attack your own solution, to crack it?
Well, I spent several evenings on it because, yeah, I do play a lot with the TNCs, etc. So for the moment, I didn't find any way when you use the hardware fuses, to actually get the AES key, and for the moment, I didn't find any way to get it. I know for AVR chips, there are ways to bypass the fuses or reset the fuses without losing the data, but I'm not sure it's possible. I didn't see anything on that kind of chips. So for the moment, I think it's okay.
Sounds like we have a reverse engineering competition tomorrow for lunch.
Sure.
All right.
I have a comment and a question. The comment is that Passwords 13 in Las Vegas, there was a talk by my colleague about like using an Android device, like sort of for the same purpose. So essentially there is attached to KeyPass running an Android device, and it can type the password. So this is one. So this is the comment, and the question is, can you explain in a little more detail the mechanics of how locking and unlocking your device works? So you mentioned that you need to lock your device and to unlock it.
I'm sorry, can you repeat?
How is your device locked and unlocked?
Okay, so the question is, can you how do you lock and unlock the device, right? Okay.
How it works internally? So
Internally.
You do something, you grip something, or whatever.
So internally, when you get to the locking system, everything in the memory is cleared in the first time, and then you are in an infinite loop that waits for you to enter your PIN code, and if the PIN code is correct, it will break from the loop and then get in the menu again.
How do you determine if the PIN is correct? Do you store some sort of hash or the PIN, and where do you store it?
For the moment, it's stored in the source code, so you have to actually get into the code to change the PIN code, and that's why we used for the moment.
So currently, you don't need to dump the EEPROM, so you only need to dump the running program if you can, and you will get the PIN.
If it would be possible, yeah.
Thank you.
So to break into this box, I wouldn't need the box. I would just need the source code you compiled on your computer. Is that what you're saying?
So this is more of a comment than a question. But one of the things that we've considered for Pico but haven't played around with very much yet is the concept of sort of implicit backup. In the sense that rather than, because such a device will probably need to be charged or whatever at a certain point, or are you getting all the power off the USB?
Yeah, everything is from the USB.
Okay.
Yeah.
So when we introduced Pico, we sort of one of Frank's original ideas, which we'll hopefully explore in the next few months, whether it actually makes sense, is to build a charging station such that you set up a relationship with that, and it delegates your credentials and the key that the charging station then has. so that you have in a backup that people actually do, because you know that people never do backups until they actually do something. And so, but by actually forcing people to do a backup essentially implicitly. So I don't know whether that applies to that kind of use case. And I don't know whether something where whenever you connect it in the command mode, maybe actually a separate hardware device it backs up onto that you keep at home might actually be quite a sensible solution. Because I kind of like, obviously there's lots of like stuff that doesn't quite work yet, but it's quite a nice idea that we try and push these kind of credentials that we perhaps care about off a general purpose computing platform onto something more specific, because we don't trust the general purpose computing platform. Sorry, that wasn't really a question.
When setting up this device, I need to connect it to a computer, or I need to log it into the device and transfer some data onto it. Now, what if the computer that I'm using is in somewhere compromised? Have you any kind of checks either in your client or on the device that will remove traces from like the host computer, so that, as Jan Felix said, if your source code is compromised, the device is still not compromised? Are you looking into that? Because I mean, the PC obviously has malware. I mean, that's obvious today to me.
So the thing is that the device only acts as a USB keyboard, so you can just plug it. There's no way to actually send commands to it unless you get into command mode, but you have to press a button, power off, power on the device, wait for 2 seconds with the button pressed, and afterwards you have to type your pin code, and then you are in the command mode. So you cannot accidentally get into command mode on an unknown computer.
And you have to enter a pin code.
Yep.
Somebody steals the device from me, and I will be like lots of other people, I will be using my birthday as my pin code. Can I have something else than just a 4-digit pin code?
You can just set the length of the pin code. For the moment, that's one of the usability problem you told. For the moment, the pin code can only be typed with the 4 buttons, so it's more a sequence than a pin code or a password. But
your password has to be a minimum of 17 mixed alphanumeric.
yeah, but so yeah, for the pin code, that's much easier, I think, to just press a sequence of buttons. You just can set the length of it, so you can just make a sequence of 14 presses of different buttons if you like to. So yeah, again, the thing is, you have it on you, just like your keys. So if someone gets your keys, yeah, well, he has to know your address, but if he has your keys, he can open your lock and get into your house or something like this. That's quite the same. The thing that makes it secure is that you have it on you.
So how exactly do I go about entering a new password into it?
The full procedure?
Yeah.
You start the command mode, and then you.
Starting command mode is a sequence of operations as well, right?
Yep.
So I have to turn off the device.
Yeah.
And I have to turn it on while holding a key.
Exactly.
And then wait for the command mode to initialize.
Yeah.
Which has now taken me how long?
And you said this is easy to use.
It's only 3 seconds.
To actually put new passwords, you don't do that often normally.
Oh, really?
If you have a serious interest in passwords, you are registering on tens or maybe hundreds of websites every week just to look at the password policy. I didn't tell you that it would be easy to do it. This is, you know, like, I gave you food, so I mean.
Alright, so now I've started it up, and then what? Do I have to use some kind of software to?
Yeah, you launch the client software.
Right, so I have to be at my computer to enter a new password.
Yeah. And it's only on computer you normally trust.
Right.
Yeah, that's one improvement that you could consider, at least when you get the USB support. Very common for instance, hardware encrypted USBs and all that is to have a two-partition device.
With the
so
client
that you
application.
so that you keep the client software off the computer that you're running it off. You still don't have a trusted path from the keyboard into the client, but and you don't have a trusted memory. But at least the client software itself should be reasonably secure.
But of course, you can also either decrease or increase the number of buttons on the device if needed, right?
Yeah, sure.
Yeah. Because I'm just thinking about the concept of having 4 buttons and how you could use that in a very usable way, easy way to enter either a normal 42 pin or a normal pin or even a password. And it really doesn't make too much sense for me on how would you be using 4 buttons to enter a pin code very easily, as an example. I mean, you could use left and right to go left and right, and then up and down to go counter up and down between 0 and 9. But again, that would also take a lot of time to enter
type your
anything
code,
else.
exactly.
Yeah, then people would be using 0000 as an example, because that would be very quick to enter, and then you have bad security again.
But you know, this is at least as secure as US nuclear.
That was actually 8 zeros. Okay. Yeah, that's a good one.
Would it maybe be easier with this kind of device to just have the device create passwords for you and then just change it on the whatever website or application you're using at the time when you
This is a possibility.
register? Then you would never have to launch the client software. You could do some simple interface via the device itself.
Directly on the client, exactly. The other thing is that we only provide the 4 buttons because I found quite cool to use the touch inputs, but you can also add a keypad. You know, the small keypads, just wire them to the TNC device, add code to handle the signals, and you're good to go. So you can make it the way you want it. That's the simplest design we have thought, but you can also maybe connect a full keyboard. You have industrial keyboards that you can actually use and connect to the TNC and use it as a real keyboard, but that would be quite huge.
Bring up voice recognition. Voice recognition. Yeah.
Yeah,
My voice is my fingerprint. Please identify me. Yeah.
Any other boards or architectures that would be suitable instead of the TNC?
Well,
Gotcha.
you should be able to do it on an Arduino, but the thing is that it doesn't emulate keyboards, so you lose the ability to let the device type the password for you. You have the Leonardo that actually emulates a keyboard, and maybe you can also use a TC 2.0, but it doesn't have a touch input, so that's less fun.
NFC RFID and send it with wireless instead of Bluetooth.
For which usage? Exactly.
Then somebody can sniff it.
Yeah, that's a good point. But isn't that what you're thinking about Pico now, to do it wireless?
Yeah.
With some protocol that doesn't
yes,
exist?
Yes, it's unpredictable. I guess with all these things, you've got to try and actually frame a threat model. Because if your threat model is only a remote attacker or someone stealing the device, then you're perhaps less worried about someone observing you use it. But for Pico, we're kind of struggling with how can we have a usable way of bootstrapping a secure connection somehow out of band from wireless. So when you Bluetooth sort of gets you to check if things are the same on both things, which is quite naff for usability. Yeah, it's difficult. And that's why it's a research project.
More questions, comments?
I was under the impression that the presentation started on 30.
Yeah.
So,
People
are there a way to watch the presentation on video? Or?
Yeah, we have been recording, so we will put out on video very, very soon. Yeah, yeah. People are starting to fall asleep after the Adobe crossword puzzle, so we have to start. Yeah. Excellent. Ah, there we have our final speaker for the day. Yep.
But that's this is just to illustrate that
That's the simple
this is the
reality.
same problem
Yeah.
for every kind of device, not only not only KeePass and things like this, but also for password. So just took this exclusively,
This
which
is
is
simple
one
rule
now.
for, IT service desk or the police or any kind of special governmental agencies. This is a very simple solution to a difficult problem. Hits him until he gives you your password. Okay, well,